In this video, we are going to learn how to solve a quadratic equation by factoring. Now, a value of x for which a function is equal to 0 is known as a zero of the function. The reason why we're going to be looking for zeros of a function is because of something called the zero product property. If two factors being multiplied are equal to 0, then either the first factor is equal to 0 or the second factor is equal to 0. Now, this is very helpful because we've just learned how to factor a quadratic expression, and oftentimes you'll end up with two factors. So looking for zeros of the function is very useful here. So right now I have the quadratic expression x squared minus 5x plus 6, and it is equal to 0. We're going to solve this by factoring. So to factor this, I need two numbers that will multiply to 6, but then add to negative 5. Now, I want them both to be negative, so that way, when I multiply them together, it gives me a positive number, but they'll still add to that negative number, negative 5. That will be x is equal to negative 2 and x minus 3. So x minus 2 times x minus 3 is how you factor that quadratic expression. And that's going to be equal to 0. So we'll set the first factor equal to 0, because that a equals 0, as you saw. X minus 2 is equal to 0, and x minus 3 is equal to 0. Because one of these must be equal to 0. Solving the left equation, we get x is equal to 2. Solving the right equation, we get x is equal to 3. So we know that the two solutions for this quadratic equation are either 2 or 3, and we can double check this by plugging them in. If I were to plug in 2, I would get 2 squared, which is 4, minus 5 times 2, which is 10. So 4 minus 10 is negative 6, plus 6, that gives me 0. Plug it in 3, I get 3 squared, which is 9, minus 5 times 3, which is 15. So 9 minus 15, which is negative 6, plus 6 gives me 0. So therefore, these are both solutions to my equation. And we shouldn't have to worry about extraneous solutions here because we aren't altering the form of this equation. We're just factoring it. So x minus 2 times x minus 3 is the same thing as x squared minus 5x plus 6. So the two solutions we end up getting should both work. And again, just to recap, the zero product property works because we know one of these must be 0. If this was 2 times 0, it would give us 0. If it was 0 times 2, it would give me 0. But if it was like 1 times 2, there's no way to get 0 without one of them being 0. Now, as I continue forward, we see here we have x squared minus 7x equals negative 12. So this is not equal to 0, so we will not be able to use our zero product property right now. And even though I could factor this left term by factoring out x, it wouldn't help me because it's not equal to 0 and I don't have a property for a negative 12 product property. So what I need to do first is add 12 to both sides of my equation to give me x squared minus 7x plus 12 is equal to 0. Now that it's equal to 0, I'll factor to see what my two factors will be. So I need two numbers that multiply to 12 but then add to negative 7. That'll be x minus 4 times x minus 3. If we double check that, negative 4 plus negative 3 gives me negative 7, and negative 4 times negative 3 gives me positive 12. And now I can set each of those factors equal to 0. And solve both of the equations to get x is equal to 4 and x is equal to 3. And they should both work. But if you wanted to double check, just go ahead, plug it in. 4 squared is 16, minus 7 times 4, 28. So 16 minus 28 is negative 12. 3 squared is 9, minus 7 times 3, which is 21. 9 minus 21 is negative 12. Now up here, I don't have a constant term, but I can still factor this expression. And it's set up for my zero product property because it's equal to 0. The common factor here is 2 and x, so I can factor out 2x, and I'll be left with 3x plus 2. is equal to 0. So my two factors are 2x, which I can set equal to 0, and 3x plus 2. The left equation, after I divide by 2, gives me 0. And on the right, I can subtract 2, then divide by 3, and it gives me negative 2/3. The solution for 0 makes sense. It could be 0 plus 0, which is 0. With the negative 2/3, if I were to plug that in, it would give me 6 times 4/9, which would be 24/9. And over on the right, we'll have minus 8/3. And 24/9 when you divide the top and the bottom by 3, you'll get 8/3 minus 8/3. So you'll still get 0 even when you plug in that fraction. So we can still get fraction answers as we solve these. Yeah, that was a check to see if that would work. Now next up we have what looks like a perfect square trinomial, because I have x squared on the left and positive 25 on the right. So we'll have x and 5. And just to double check to see if it is a perfect square trinomial, I would have to use negative 5 to get this negative 10. So if I multiply the two terms together, x and negative 5, that gives me negative 5x, and twice of that is negative 10x. So yes, this is a perfect square trinomial. And now I only have one factor left. I have two x minus 5s. I could even take the square root of both sides of this equation. And I'll be left with x minus 5 is equal to 0 after I take a square root. And now I only get one solution. So even though we've been getting two solutions every time so far, you can still possibly get just one solution. Which if I were to plug this in, we have 25 minus 50 plus 25, which will give me 0. Now the last equation, I have everything on both sides of my equation, but I move everything to the left. And the reason why I'm going to move everything to the left rather than my 3x to the right is I like to have a positive x squared term. It makes factoring easier. So I'll subtract 16x, give me 3x squared minus 16x. Subtract 12 minus 12x, and now it's equal to 0. But there is no common factor like I saw in the top example in the right column. So I'm going to have to use the a times c method by multiplying 3 times negative 12, which gives me negative 36. And we need to find two numbers that multiply to negative 36, but then add to negative 16. That will be 2 and negative 18. Because 2 times negative 18 is negative 36. 2 plus negative 18 is negative 16. Now I'll use factoring by grouping, by splitting up that middle term into 2x minus 18x. And I'll still keep the 3x squared and the minus 12. And I'll group the first two terms together. And the last two terms together. In the first group, the common factor is x. And when I factor that out, I'm left with 3x plus 2. And in my second group, there is a 6 in common, but they're both negative, and I see on the inside of this factor they're both positive. So I'm going to make that a negative 6x I'm going to factor. A negative 6 I'm going to factor out. And when I factor out negative 6, negative 18 divided by negative 6 is positive 3x, and negative 12 divided by negative 6 is positive 2. And we'll see our common factor is 3x plus 2. And when I factor that out, I'm left with x minus 6. And now that this is factored, I can set both of those factors equal to 0. So I'll have 3x plus 2 is equal to 0, and x minus 6 is equal to 0. And my two solutions will be negative 2/3 and x is equal to 6. And that is how you solve a quadratic equation by factoring.